You've probably sent a message to an AI and gotten back something fine, reasonable, maybe even impressive on the surface. But if you've ever asked it to do something genuinely complex, research a topic, write a full report, build a content strategy from scratch, you've probably noticed something. It starts to wobble. It forgets earlier instructions. It contradicts itself. It gives you a decent start and then slowly drifts away from what you actually needed. What if that's not a limitation of the model, but a limitation of how you're using it? Here's a mental image. Think about the assembly line. Before Henry Ford industrialized car production, craftsmen would build entire vehicles by hand, one person doing everything from chassis to engine to upholstery. And the results were inconsistent, slow, expensive. Then someone had an idea. What if instead of one person doing everything, you had a series of specialized stations? Each station does one thing, does it perfectly, and then passes the result to the next station. Nobody tries to hold the entire car in their head at once. That's a prompt chain. Instead of one prompt trying to do everything, you build a sequence, a pipeline of prompts, where each step has a single, focused job. The output of one step becomes the input for the next, and the whole system, working together, can accomplish things that a single prompt simply can't. This isn't just an efficiency trick. It fundamentally changes what's possible with AI. So let's start with the most fundamental form of chaining, the sequential chain. Imagine you're sending a letter through an office. You write it, hand it to a messenger, the messenger delivers it to a secretary, the secretary routes it to the right person. Each step depends on the previous one being completed. Information flows in one direction, clean handoffs. That's exactly how a sequential chain works. Step 1 runs. It produces output. That output gets passed, sometimes programmatically, sometimes manually, to Step 2 as its input. Step 2 runs, produces its output. That becomes Step 3's input, and so on down the line. Let's make it concrete. Say you want an AI to produce a market research summary on electric vehicles. In a single prompt approach, you'd ask, "Research electric vehicles and give me a summary." The model tries to retrieve, evaluate, structure, and format all at once. That's a lot of variables in the air simultaneously. In a sequential chain, you'd build 3 stages instead. Stage 1. Generate a list of the 5 most important trends in the EV market right now. That's all it does. Stage 2 takes that list and says, "Here are 5 EV market trends. For each one, write a 2-sentence explanation of why it matters to investors." That's all Stage 2 does. Stage 3 takes those explanations and says, "Here are 5 explained trends. Synthesize them into a coherent executive summary with a professional tone." That's all Stage 3 does. Notice what happened. Every stage is focused. Every stage has a defined input and a defined output. The model never has to hold the whole problem in its context. It just handles its one piece of it. And here's the practical upside. Each stage can be optimized, evaluated, and fixed independently. If your summary sounds off, you don't have to redo everything. You just fix Stage 3. That's the power of decomposition, and it's why every serious AI workflow eventually evolves toward chaining. Now, there's a crucial distinction to understand here, and most people miss it. A sequential chain isn't just about output flowing forward. It's about context being managed deliberately at each stage. Each prompt only gets the context it actually needs, not the full, sprawling conversation from the beginning of the pipeline. Think about it like a relay race. The baton passes from runner to runner. Each runner doesn't carry the previous runners on their back. They just receive the baton and run their own leg. Clean handoff, focused effort. When you feed the full conversation history into every stage, you risk something called context drift, where the model starts getting confused by earlier instructions that are no longer relevant. Constraints from Stage 1 start interfering with Stage 3. The model tries to satisfy conflicting signals it's picked up along the way. Chaining prevents that by giving each stage a scoped, intentional context window. This is actually one of the biggest unspoken advantages of chaining. Most tutorials don't emphasize it, but it matters enormously in practice. Okay, sequential chains are one pattern, steps happening in a specific order, each depending on the last. But there's a second, equally powerful form of chaining where, instead of steps happening in sequence, they happen simultaneously. Back to the factory analogy. In a car plant, not everything runs in sequence. While one team works on the engine, a completely separate team works on the interior. These are independent tasks. They don't need each other. They run in parallel, and then all the results get merged at the end. That's a parallel chain. Independent prompts, with no dependencies between them, run at the same time, and then their outputs are combined into a single final result. Let's make it concrete. Say you're building a detailed profile of a competitor company. You could run these prompts simultaneously. Prompt A: research this company's product features and key differentiators. Prompt B: research this company's pricing strategy and positioning. Prompt C: analyze this company's customer reviews for recurring themes. None of these prompts needs to wait for the others. They're completely independent. You run all three in parallel, and then you feed all three outputs into a final consolidation prompt. Here are 3 research reports on a competitor. Synthesize them into a single, comprehensive competitive analysis with clear sections. Same quality result, but potentially 3 times faster if you're running those parallel stages efficiently. Parallel chains are especially powerful when you have a single topic that needs to be examined from multiple angles simultaneously. Different questions, different lenses, and then reassembled into a coherent whole. There's also a third subpattern worth knowing: voting chains. In a voting chain, you don't run different prompts on different subtasks. You run the same prompt multiple times on the same input. Why would you ever do that? Because AI models are stochastic. They don't always give you the same answer twice. If you need a high-confidence output, a risk assessment, a factual classification, a critical judgment call, running the same prompt 3 times and comparing the results reveals whether the model is confidently consistent or genuinely uncertain. If all 3 runs agree, confidence is high. If 2 disagree with one, there's reason to investigate. If all 3 diverge, the question itself may be fundamentally ambiguous. Voting chains are deeply underused, especially for any analysis where being wrong has real consequences. So now you've got the full picture of chaining patterns: sequential for ordered steps, parallel for independent tasks that merge, and voting as a confidence-building subpattern. But here's the question that serious practitioners have to ask themselves before designing any chain. Let me be direct. Chaining is not always the right tool. I know, we just spent a good while making it sound incredible. But part of being genuinely skilled at AI workflows is knowing when not to add complexity. Think of it like surgery. A surgeon with a scalpel can solve serious problems, but if you have a headache, you need aspirin, not surgery. Reaching for the most powerful approach on a simple task just makes your system slower, more expensive, and harder to maintain. Here's the framework for deciding when chaining is necessary. First condition: task decomposition is genuinely required. The goal involves distinct logical leaps, where the cognitive operation required for each step is actually different in kind. Researching is different from filtering. Filtering is different from synthesizing. Synthesizing is different from formatting for a specific audience. If those are meaningfully different mental operations, they likely belong in separate stages. Second condition: context window limits are a real constraint. If your input is a 100-page document or you're accumulating a large amount of text across a long workflow, a single prompt can't hold all of it cleanly in its attention. Chaining lets you manage precisely what each stage sees, preventing information overload and keeping each prompt focused. Third condition: high probability of derailment without structure. If the task is complex enough that a single prompt tends to lose track of its constraints halfway through, forgetting tone instructions, drifting from format requirements, ignoring the first few rules by the time it processes the last, that's a clear signal the task needs to be broken up. Now the flip side. Chaining is overkill when the task is simple, deterministic, and low in nuance. If you need to classify an email as urgent or not urgent, that's one prompt. No pipeline needed. Adding a three-stage chain to classify an email doesn't make the classification better. It makes your system slower and more expensive with zero benefit. The most common mistake new practitioners make? They build elaborate pipelines because complexity feels sophisticated, not because the task actually demands it. Ask yourself 3 questions before adding any chain. Does this task involve genuinely different cognitive operations at different stages? Is the input too large or the context too sprawling for a single prompt to handle cleanly? Does a single prompt actually fail or drift on this task, or does it handle it fine? If the answers are no, no, and it handles it fine, don't chain. Resist the reflex. That brings us to the final concept in this lesson, and it might be the most important one for anyone planning to build real AI systems at any scale. Here's a statement that sounds paradoxical at first. More pipeline stages can make your output dramatically better and simultaneously make things go wrong in entirely new ways. How can both be true at the same time? Let's think through it layer by layer. Every stage in a chain costs something. Sometimes literally. If you're calling an AI API, more stages means more API calls, more compute, more tokens, more money. But even if cost isn't your concern, every stage costs latency. A 3-stage pipeline takes at minimum 3 times as long to complete as a single prompt, assuming the stages run sequentially. And every stage introduces a new opportunity for failure. If stage 1 produces output that's slightly off, stage 2 inherits that slightly off output and builds on it. Stage 3 then inherits stage 2's interpretation of an already imperfect product. Errors don't stay isolated, they compound. This is called error propagation, and it's the shadow side of the chaining superpower. Think about the game of telephone. You whisper a sentence to someone, they whisper it to the next person, down a line of 10 people. By the end, the original message is often completely transformed, sometimes unrecognizably so. Every link in the chain introduced a small distortion. All those distortions stacked. So the design principle here is simple but profound. Build the shortest, reliable path to your objective, not the most elaborate, not the pipeline that looks most thorough on a diagram. The shortest path that reliably produces the result you actually need. If 3 stages do the job with high reliability, a 5-stage pipeline isn't better. It's just more fragile, slower, and more expensive. Every additional stage has to justify its existence with a measurable, demonstrable improvement in output quality. The engineers who build the most powerful AI workflows in the world are the ones who relentlessly prune. They start with the simplest possible chain and only add stages when they have a clear, specific reason, not because it feels more complete. There's one more dimension to this trade-off that's worth keeping in mind: visibility and debuggability. A shorter chain is easier to debug. When a 6-stage pipeline produces a bad final output, you have to examine every stage to find where the fault originated. Was it stage 2's filter that removed useful information? Stage 4's synthesizer that introduced a wrong inference? Stage 5's formatter that broke the intended structure? That's why experienced AI architects always evaluate each stage's output independently, not just the final output. You look at intermediate outputs too, because that's the only reliable way to locate exactly where a failure happened and fix just that piece without touching everything else. So let's pull everything together. A prompt chain is a structured system where AI prompts are connected, each stage handling a specific, focused task, with outputs flowing forward as inputs to the next. Sequential chains handle tasks that have natural ordering, where one stage genuinely depends on what the stage before it produced. Parallel chains handle independent tasks that can run simultaneously and be merged, unlocking speed and enabling analysis from multiple angles at once. Voting chains extend this by running the same task